In this video we're going to look at a couple more of examples using the compound angle identities. We're also going to look at a couple of different properties of sine, cos and tan and how that links to right angle triangles. Okay, so the first example in the booklet is actually very similar to one that we did 2 videos ago, but I thought I'd start with this one anyway as a bit of a recap. So it says by using the formula for sine of a minus b, without the use of a calculator, show sine of 15 degrees is equal to root 6 minus root 2 over 4. Okay, so clearly without the use of a calculator we've been asked to do this. And if you think back to the other video, these common trig ratios are ones that we're expected to remember from GCSE. So what could we do with 15 degrees? Okay, hopefully we could spot that we could write 15 as 60 minus 45. Okay, I've just noticed actually we could also do it as sine of 45 minus 30. There's 2 ways to get this answer. I'm going to do 45 minus 30. Okay, you could do that way, it'd also give you the same answer, maybe check after this. Okay, so sine of 45 minus 30, we can write it as sine of a minus b. So that would be sine of a cos of b minus cos of a sine of b, which would be sine of 30. And then if you can't remember these, you could then type into your calculator cos 30 to see what cos 30 was, but hopefully we could use these triangles. So sine of 45 is 1 over root 2. Cos of 30 adjacent over hypotenuse, so root 3 over 2. Cos of 45 adjacent over hypotenuse, 1 over root 2. Sine of 30 opposite over hypotenuse, so half. Okay, all we've got to then do is just to get it into this form that we're being asked for. Okay, let's take a common factor out, so 1 over root 2. We have root 3 over 2 minus a half. Let's rationalise this, so times by root 2 on the top and root 2 on the bottom. That gives us root 2. Root 2 times by root 2 on the bottom gives us 2. Combine these, so it would be root 3 minus 1, because we can subtract these fractions, they've got the same denominator. And then just expand out, so root 3 times root 2 gives us root 6, minus root 2. 2 times 2, 4. Okay, so part B says given that sine A is equal to 4/5, where A is acute. That's really important actually. We'll come back to that in a minute. Find the value of sine of 2A without use of a calculator again. Okay, so you might think, if you're able to use a calculator, well, if I know sine A is equal to 4/5, you might just go, well, A is equal to sine inverse 4/5. Let's just check actually, let's see what happens when we do that. So shift sine 4/5. Well, you get 53.1301. It's not a nice answer. Okay, and also we're not allowed to use a calculator, so we don't want to do this. But the main reason why we're not using the calculator is because we want to avoid this. It's not a nice trig ratio. It's going to give us an awkward answer. Okay, so let's do something slightly different. You remember what I keep saying about trigonometry? It's all about like right angle triangles. Let's essentially use this information. Draw a triangle. So think about what sine is. Sine is opposite over hypotenuse. So we've got 2 sides of a triangle. We've got the opposite side. So if that's A, the opposite side would be 4. We've got the hypotenuse, which would be 5. Hopefully this is familiar. Right angle triangle. That side's going to be 3. If you're not sure when you've drawn your triangle out, if you know 2 sides, you can just use Pythagoras to find the other side. Okay. So now that we've drawn this out, from this triangle, I can see, well, what would cos of A equal without using the calculator? Now, cos is adjacent over hypotenuse, so I straight away know cos of A is equal to 3/5. And if I needed it, I would also know that tan of A, tan is opposite over adjacent, would be 4/3. Without even figuring out what the angle A is, I don't care about what the angle is, it's like 53 point something degrees, but without caring about that angle, if I know what sine of A is, I can figure out what cos of A is. I can figure out what tan of A is. Okay, the fact that it's acute, let's think about what that's telling us, because we'll see something in the next example where it's a bit different. Hopefully you can see this. So if I sketch these functions, we've got the three trig graphs. We've got sine, which is blue, we've got cos, which is red, and we've got tan, which is green. And I've drawn them in degrees. Okay. Now, when we're talking about an acute angle, we're talking about somewhere between 0 and 90. All that's telling us is if it's an acute angle, you can see the sine, cos, and tan, they're all going to be positive. So say, for example, if I did sine of 30, cos of 30, or tan of 30, I'd always get a positive answer. Where it gets a bit more interesting, and I'll speak about this now, if we move to the obtuse angle, so if it tells us something's obtuse, sine is still positive. So if I did sine of 120 or sine of 150, if I do sine of an obtuse angle, it would be a positive. But if I did cos of an obtuse angle, so say for example, if you did cos of 120, you're going to get a negative answer. If you did tan of 120, you're also going to get a negative. And you might even see reflex, which is more than 180. So if it's between 180 and 360, notice that if it's between 180 and 270, so between 180 and 270, tan is positive. So if we knew it was reflex, if it was between 180 and 270, we'll know tan will be positive, but sine and cos would be negative. You can, use your graphical calculator and have a little play about with this, like work out what sine of 210 is. You'll see that it's a negative answer. So acute, all positive. Obtuse, sine is positive. Reflex, between 180 and 270, tan is positive. And if we go one step further to between 270 and 360, cos is the only positive one, so the others would be negative. Okay, we'll see that in the next example as well. So the question says, find the value of sine 2a. Very important identity for this one. Sine 2 theta. We know is 2 sine theta. Cos theta. So sine of 2a would be 2 sine a. Cos a, which would be 2 lots of, well, sine of a is 4/5. And cos of a is 3/5. So that would give us 5 times 5, 25, 8, 24. That's 25. Without using the calculator. Okay, so example 2 gives us two ratios. It says sine of a is minus 3/5 and cos of b is minus 12/13. Now we know the angle A is somewhere between 180 and 270. Okay, so if you want to check between 180 and 270, we know that for A, sine and cos would be negative, but tan would be positive. B is obtuse, so obtuse is up here, sine is positive, the other two are negative. Okay, don't worry about drawing it when you do. Like, I'm still going to draw a right angle triangle and think about the ratio. Like, we've got a 3, 4, 5 triangle. Okay, technically, I mean, I'm going to think about A being here inside, but really it's because it's a reflex angle between 180 and 270. It's really like going that way around, and you've measured an angle which is a reflex angle, but just draw a right angle triangle, don't overthink it. We know sine is opposite over hypotenuse, so we've got the 3, 4, 5 triangle again. So cos of A would equal cos is adjacent over hypotenuse, 4/5. But we're working between 180 and 270, and the cos graph would be negative, so it's going to be a negative value. Okay, tan of A is, tan is opposite over adjacent, so it'd be 3/4. And in that interval, tan will be positive. Okay, let's draw the triangle for B. Again, B is obtuse, so you could probably think about it being that side over there, or this bit in here, where you get an angle bigger than 90 degrees, but just draw a rectangle triangle. Cos is adjacent over hypotenuse. Okay, so is that right? We've got 12 over 13, yeah. So we're going to have to work out what this side is. Okay, we've got 13 squared would equal 12 squared plus, I'm going to call it O for opposite, squared. If you do 13 squared minus 12 squared and square root, then we end up with 5. A lot of you probably will have spotted that already. It's another Pythagorean triple, isn't it? 5, 12, 13. But don't worry if you didn't spot it, we can just use Pythagoras to figure out what it was. Okay, so what's cos of B? Oh, sorry, we already know that, don't we? So let's work out what sine of B is. So sine is opposite over hypotenuse. We're working with an obtuse, so sine will still be positive. Tan is opposite over adjacent. And for an obtuse angle, tan would be negative. Okay, so now we can actually answer the question. Alright, it says find the value of cos of A minus B. Okay, you might want to refer to these, remember you get them in the formula booklet. Cos of A minus B is cos A cos B plus sin A sin B. So then we can just fill in what we know. So cos of A is minus 4 over 5. Cos of B is minus 12 over 13. Sin of A is minus 3 over 5. And sin of B is 5 over 13. Okay, use your calculator to work that out. We should end up with 33 over 65, I think. Okay, have a go with those two, pause the video and see how you get on. Okay, so I filled in the blanks. Just using the ratios, you should get 16 over 63. And cosec, don't get thrown by that one. Think about it as 1 over sine. And then you know what sine of A plus B is. You should get 65 over 16. Okay, so I've had a little look, and example 3 and example 4 should be able to follow those using the word solutions. Okay, all it's using is the cos of A plus the minus B, sin of A plus minus B formulas. Once you've worked through those examples, example 3 and 4, have a go at exercise 1. And obviously use the word solutions and let us know if you need any help. Okay, thank you.